to understand OSPF NBMA network types, we are going to have frame relay in this topology. So we are going to focus on how to configure frame relay and OSPF today. In our next class, we will be seeing the 5 different types of NBMA, but today my focus is on the bringing up of this frame relay network with OSPF and the first one out of 5. The first one out of 5 modes is called as non-broadcast mode. Non-broadcast. This is according to the RFC standard. The first one is non-broadcast. You see, I have written all the 5 types. The first one is non-broadcast. I'm going to explain this non-broadcast once I finish the basic configuration. R1's configuration is this. I've just shown you here the IP address only. We are not going to enable OSPF now. First, let us bring the topology with frame relay up. You understand? First frame relay. Now this I'm going to paste it on router 1. Next, router 3. Next, router 4. Okay. Now the next thing is, why did I enable 10001, 10003 and 10004 on serial link? Because only on the serial link we can enable frame relay. Okay, so the default encapsulation type, if you notice here, it is HTLC. Show IP interface, no need of IP. Show interface serial 1/0. If you see here, the default encapsulation type you will see as HTLC. Now, there is another protocol called PPP, interface serial 1/0 encapsulation PPP. This is also available. Okay, but I'm not going to enable PPP. I just showed you I can change from HTLC to PPP. But I'm not going to enable PPP. We are not learning PPP here. We want to have frame relay. So I'll go inside the serial 1/0 once again and I'll say encapsulation frame relay. Yeah. Now next, what I would like to show you is the interface status. After I enable frame relay, you can see the encapsulation type is frame relay, and you can see something called LMI, DLCI, LMI type Cisco, blah blah blah. What is these things? These things are the protocols of frame relay. LMI stands for Local Management Interconnect. Local Management Interconnect. DLCI or DLC, it stands for Data Link Connection Identifier. You see, DLCI, I have also written here. You see, DLCI, the board background. Do you see the numbers? Okay. Now, this is like a MAC address for frame relay. Okay, so this is the way which frame relay identifies. Now, That is frame relay. Okay. Now there is the local management identifier LMI. There are three types, LMI types. One is Cisco, because this is a Cisco router destroying Cisco. The other two are Q933A and ANSI. If I ask you to repeat, definitely you will not repeat. But anyway, that is not important also. You want me to repeat again? I'll repeat. LMI types are three types. One is, tell me what is the one. You already see that on the board. Tell me that. Hmm. Which one, sir? I'm sorry. You're not focusing on class. I'm talking about LMI and you are saying something else. But you did not focus. LMI types are of three types. In frame relay, there are three types of LMIs. One is Cisco, another one is ANSI. Uh, don't speak something which is not connected. I think you did not listen for some time. DLCI is just an identifier. I'm talking about LMI types, local management identifier type. Now, I was telling you DLC number is like MAC address. Why you are comparing address to the type? I also told you that later you watch this video, what mistake you did, you will understand. I also told you that LMI type is not that important. Do you want me to repeat? You said yes, yes, repeat. But when I ask you what I'm going to repeat, you don't know. So there is three type of LMIs: Cisco ANSI, ANSII, ANSI, and Q933A. If you want, I can show you. But those things are not important. I tell you, on those days when we were having frame relay, these things were important. You see, frame relay LMI type. Hmm. The default is Cisco. If it is other, nothing, nothing. This is a negotiation protocol. That's all. Cisco uses Cisco's own negotiation protocol. Other vendors may have ANSI by default. Q933A is another optional one. This is just for negotiation. Frame relay link. No, no need to say anything like that. I said LMI type. That is how you should call. Hmm. Okay, now I showed you frame relay enabled on this interface. Let us go and enable frame relay on the other two routers. Interface serial 1/0 encapsulation frame relay. Likewise, go to R4. Interface serial 1/0 encapsulation frame. Right. Now frame relay is running on all the three routers, but what is the use if the environment in the middle don't support frame relay? So you need to make a frame relay switch in the middle. I don't have a switch. Do I have a frame relay switch? Tell now. Do I have a frame relay switch in the middle? Is this a frame relay switch? It's just a router. So now, can I make a router a frame relay switch? Yes. It can be a router. At the same time, if you enable frame relay, it can also be frame relay switch. It is not changed into frame relay switch. It is also a frame relay switch. You understand? See, router 2 can be a switch, frame relay switch. At the same time, for some other traffic, it can also be a router. Understand? See, I will go and enable frame relay switch here, which doesn't mean that routing is disabled. No. Routing is also running at the same time. So I can have one interface here and here with IP address and run OSPF in this track routing. Whereas in this track, I'll have only frame relay. You understand? So the middle router can be both. It's not so important today, but a few years back, it was very important. Why? Because in CCI exam, we used to run OSPF in router 2, and also router 2 will be a frame relay switch for router 1, 3, and 4. We used to have scenarios like that. But now frame relay are all remote. Nowhere in the exam you will find it. Okay, now how to make router 2 as a frame relay switch? Frame relay switching, that's all. This command enables frame relay switching feature on this device. I don't want to call this router now because it's also a frame relay switch, so I would like to call it as mid device. I don't want to call it a switch also because it can be a router also. So if I say switch, then you will think that it is not routing. It is not going to route. See, you still have a routing table. You see, routing table is still there. EIGRP you can run. So now when I type show frame relay route, there is no route, but frame relay is enabled. When you see this, you say no, routing is enabled. Likewise, when you see this, you should say frame relay is enabled. But it is not enabled under the interface. There is no interface member of frame relay. Okay. Now let us go to those three interfaces first. Interface serial 1/0, no shutdown. Interface serial 1/1, no shutdown. Interface serial 1/2, no shutdown. Now we brought the interface up. See, these three interfaces are up, right? Now, first thing is what I want to do is I want to say interface serial 1/0 encapsulation frame relay. You know this command, right? Likewise, I'll go to serial 1/1 and say encapsulation frame relay. And then interface serial 1/2 encapsulation frame relay. Done. Now, up to this level, you know. Now, next what I want to do is I want to first teach, and then I'll take you to the configuration. You see, I want to put a pipe. See, this is already frame relay. This end is frame relay, this end is frame relay. You agree? Likewise, this end is frame relay, this end is frame relay. Yeah? So, where we need frame relay now, frame relay is needed between the ports of the frame relay switch. I want frame relay between the ports. So, meaning I want a frame relay pipe. You understand? I want a frame relay tube. I want a frame relay wire, a virtual logical wire between this port to that port. Say something, yes or no? Yeah, my dear. We are going to do on the interface. But inside, through configuration, I need to connect these two for frame relay. These two for frame relay. Because in the real world, there may be many physical interface. You may not be running frame relay there. They will be doing routing. Of course, this is layer 2. This is layer 2. That is layer 3. Now, I need this. This is what I am trying to tell you. I need a pipe between. If someone is going from R1 to R3, I want this pipe to be used. And if someone is going from R1 to R4, I want this pipe to be used. You understand? This pipe is called as PVC pipe. Have you seen PVC pipe in your house? That is polyvinyl chloride. This is permanent virtual circuit. I'm not joking. PVC is real name only in flame relay. But it is not polyvinyl chloride. It is permanent virtual circuit. Permanent. Ah. So how many PVCs I need? Because I have two branch office, I need two PVCs. Okay. And this end of the PVC, I want to give a number. I have given 301. This end of the PVC, your wish. You can call it as branch or head office, your wish. End of the day, these three need to communicate. Mostly, they will keep R1 as the head office. You know why? Because frame relay is very costly. They will not go for full mesh. They will go hub and spoke. If R4 wants to talk to R3, there is no PVC here. There is no PVC to go like this. So they used to go to the head office and routed to the other branch. You understand? This is what called as hub and spoke. In that case, then R1 is the head office. Your wish. You want to have head office as a hub or branch office is your wish. But mostly head office is going to be the hub. Now, but I'm trying to say something, but you have diverted me to another line. Listen, I was talking about PVC, my friend. PVC, this end needs an ID. I'm giving 301. Same PVC, the other end needs another ID. So I'm giving 103. So the pipe, the pipe, what is the pipe name? One end of the pipe is 103. Another end of the pipe is 301. And again, another pipe. One of the end is 104. Another end is 401. So this end is 104. This end is 401. You got it? How to put this pipe? Let's see. We call this frame relay route. Frame relay route. PVC. How do you put PVC? By putting route, frame relay route. So let me show you the configuration part. Right now, when I type show frame relay route, I don't see any route. But when I go to interface serial 150 and say frame relay interface INTF type DCE. Don't forget. Anyway, you forget this, not important topic. But if you want to know frame relay, you should know this. Frame relay interface type DCE, and then frame relay route command. For what you are doing frame relay? IP. Sorry, frame relay route. Okay, del C number. What is the number? This end from 1 to 3. Okay, that is 103. Yeah, 103 is on which interface? Serial 1/0 or 1/1? Very good. And then exit interface is serial 1/1, isn't it? What is the number there? Uh, that's all. That's Atlanta. Okay. 301. Right. Now let's go to the sorry. On the same interface we have another PVC, no? Frame relay route 104 interface serial. What is the interface? MD. I'm already inside that, no? What is the exit interface? Oh no. What's the you are an expert of frame relay now. You already answering. Okay. Chala santosha. Next. You see, let me show you. Show frame relay route. You can see two routes going from serial 1/0 to 1/1, another one 1/2. But it is inactive. You know why it is inactive? Even though we have said no shutdown here, this two is still not configured. See, I need to go under interface serial 1/0 and say encapsulation frame relay. Likewise, we have already done on other interface, but what is not done is the route command. Frame relay interface type DC frame relay route చెప్పండి. అవును, same router another interface kada. My friend, we did in this direction, yeah, on this port. You need to do it now in this port towards this. Only then these two can join, these 2 points. Huh? Now frame relay route, what is the number here? 301 exit interface serial 1/0 103. Ante. Interface serial 1/2 frame relay no INTF type DCE frame relay route 401 interface serial 1/0 104. Now you go and see. Show frame relay route. Look at this. All are active. Very good. You don't need to do on R1, R3, R4 the route command. You need to simply say their encapsulation frame relay. You remember we did that. R1, R3 and R4, we said encapsulation frame relay. That is important because you want to talk to frame relay switch on R1, R3, R4, you should mention frame relay is the encapsulation. Now next is, you will see one magic. What is that? You did not say any root command here, isn't it? Where did you configure 103, 104 and all? You did not configure anything on R1, right? Like that. But you see here, show frame relay map command, not the route command. On the frame relay, you need to say route command. Here you need to say map command. You can see the magic. Magic is already router 1 knows the other two guys. 103, if I need to go, I need to send the packet to 103. If I want to go to 10003, I need to send to which DLCI? చెప్పండి. If I want to go to 10003, I have to send it to 103. See, it has automatically learned already, dynamically it has learned. And if I want to go to 104, I need to go to 104. Sorry, 1004, 10.08 going to 104. Only then it can go this direction, isn't it? Likewise, if you go to router 4 and check, it will show you to go to 10.00. Why 104? R4, if it wants to go to 10.0.0.1, it will go to 401, not 104. From R4, let's go check. So, that we already spoke, no? You see? How is this learning this thing? It learns through a protocol called inverse ARP. What ARP? It's not ARP. It is inverse ARP. Not R. ARP. ARP, no? ARP. ARPing. Show interface serial 1/0. I'll show you here. Inverse ARP. Oh, where are you? Inverse ARP is a protocol that helps to discover this. Inverse ARP show frame relay interface. Not only ARP, but the protocol name is inverse ARP, okay? That is the one which is helping to discover. Okay. Now, show frame relay. There is no discovery between R3 to R4 because we don't have a PVC there. Because frame relay is very costly, we will not put full mesh PVC. We will go through the hub only in the real world. If you want me to put a PVC, it's easy. We can put for one PVC, then it will go directly like this. You need not to go to here and come back here. But in the real world, that is not the way that they did. They were using hub. Okay. Now frame relay is ready. I'm going to enable OSPF. You see now. Interface range, comma, serial. Okay, it's not possible with serial and loopback. I'm going to do alone separately. IP OSPF 1 area 0, interface loopback 0, done. Okay, to show history. See, it should be in same area to form neighbor. You don't know OSPF. The other packets will try to match with the area ID. What happened to you? I don't know. No, not possible. No. Show frame relay. Sorry, show IP OSPF interface brief. You can see OSPF is running, but it won't form neighbor. Let's go and enable OSPF and then come and check. It won't form neighbor. I'll close router 2 because frame relay switch is already ready. I'm going to router 3. Interface loopback 0, IP OSPF. Now we only are coming to normal headset. For this long you were very far away. Interface serial 1/0, put the same command. Now, the OSPF neighbor will never be formed because the middle one is a non-broadcast environment. That's why it is called as NBMA. So what is the solution? You see, show IP OSPF interface serial 1/0. Look at this. The hello timer is 30. Don't forget. Tomorrow I'm going to repeat this. In WAN, hello timer is not 10. It is 30. And what is the network type by default? It is not broadcast. It is non-broadcast. It will be there, but first of all, neighbor should come. No, only then DRBDR will come. In non-broadcast, multicast is not supported. Then how neighbor will come? It won't come. No. So we have to manually configure neighbor like this. Router OSPF 1 neighbor 10.0.0.3 neighbor 10.0.0.4. Likewise, you need to go to router 3 and say router OSPF 1 neighbor 10.0.0.1. Oh, I put network, sorry. Router OSPF 1 neighbor 10.0.0.1. Likewise on router 4 interface serial, router OSPF 1 neighbor 10.0.0.1. Now you will see neighbor coming up. You see, neighbor has come up. Show IP OSPF neighbor. You see, you have DRBDR. Do you have DRBDR? But there is a drawback in this. We'll discuss that in our next class.